Fix-it problem from yesterday. So this was the first one we did. Thanks, Victoria, for pointing out to me that I did make a dodo error. I'm assuming that many of us caught the dodo error. Did you guys notice what the dodo error was? It's when I took my derivative here, that piece should just be at 0, right? As Mr. Kulik doing just boogered it. You ever just booger a problem? Yeah, it happened to me right there.
Wouldn't it be plus 360?
Oh, yeah, sure. Thanks. That'd make a lot more sense, right? We'd expect this thing to be growing rather than shrinking. That's probably why I didn't catch it, because I made two errors that both kind of canceled each other out in a way. And then we got, what is there, pi over 90. You guys got a serious case of the giggles going on over there. We got 2 square root 189. That makes a bit more sense. What, about 390.396? Okay, thank you for the error reporters on that. That would have been a bad one to have left just kind of hanging, right? All right. And then I think I had one more that I had picked out that I wanted to do that I just didn't include last time because, well, it felt like it was enough what I had given you guys to work through in one class period. And it was one that was complicated enough that I didn't have my answer key with me. And I'm like, I think I have this, but I don't trust it enough to not like look at the answer before I publish it for something on video for you guys. So let's do that one now, and that's just the last one on this stretch here. So this is a 4-7 problem. So it says that a right circular cylinder is inscribed in a cone with a height h and a base radius r. Find the largest possible volume of such a cylinder. You guys want to start trying to do this and then we'll go through it together? Yeah. So get something out, scrap paper, notebook, folder, tablet, whatever you want to write on. Just try to work through this. We'll go for 10 or so minutes and then I'll see if we're stuck or if we want to pause and see a little bit of it and then.
Can I just ask a question?
Yeah, absolutely.
What is inscribed in a cone?
Okay. That means the cylinder is inside the cone.
Oh, it's right.
Let's see. I'll go and Google image search a decent picture. That looks acceptable. Copy image. Actually, I'm going to keep on looking. I want to see if there's one that I like a little bit better than that one. Yeah, that one's even better. I'll take that image. So this is what you got here, is something that looks like this. After we do this one, I'll turn it over to just like answer anything you guys want me to talk about. But I feel like this is a good one to go through. This is pretty representative of kind of what I'd expect you to be able to do.
Wait, the height of the cylinder is it?
Okay, so I guess in this drawing,
Oh, it's both.
this picture has cap H and cap R for the cone, and little h and little r for the cylinder. So let's go ahead and do that. Well, this would be part of like a 10-point multi-part question. So like I would, like there would have been like 5 or 6 parts to it where I would have given you breadcrumbs to like get you to the final answer. Like one of them might just be like, here's a picture and I've labeled the vertices, like this one is like A, B, C, D, E, whatever, and might have just asked you like, okay, write in terms of like X, Y, you know, X, Y, R, H or whatever, A, B, C, D, well, you know, like label a picture with some reasonable variable names for these things. You know, like that might be 1 point. Like nothing, no calculus involved, just like labeling a picture. You know, like I would, and a problem like this, I'd probably given you the picture, Mackenzie. Oh, like a bunch. You know, like it would then be like, you know, yeah. So I would have had like, you know, I would have been like, you know, label the diagram. I'd give you the diagram and ask you to label it with like, you know, like where we have the little labels in here, I might ask you to label some stuff. And I'd probably give you a little bit more than just the phrasing that's here if I was asking you to label stuff a certain way. And then I would be like, you know, like say, show that, you know, the volume of the cylinder is equal to yada, 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 where it's the form where it's eliminated down to a single variable. And that would probably be more than 1 point to do that. That's kind of complicated. But the nice part about that is I've given you what the volume is with one variable. I've done the hard part, right? Because it's a show problem. So can you do the calculus and stuff afterwards? Yeah, because you have the correct volume formula. I've given it to you, right? You know, like another would be like, what's the domain for the volume equation? That'd probably be another part. You know, like what are the critical values I need to check? Or if to find the max or min for the problem, like what values of whatever the variable is in question do I need to check? You know, like it'd be stuff like that where it's like I'm trying to give you the steps to do the problem as the parts of the problem. So that like if you forget to like, oh, is the domain, I forgot to do the domain, is that important or not? Well, I'm going to ask you what the domain is so that you remember to do it, you know. So I'm going to try to, I tried very hard to structure these multi-part problems in a way that like, even if you muck up one part, the important part is a show question where you can use that answer to do the rest of it.
I mean, like, how many electronic tests would we like 4?
Oh, I think I had, so there's like 70 points of like singleton questions where there were no parts to it. Just like one thing, like do this, do that. And there's like 50 points of multi-part questions. So I think there's 5 10-point multi-part questions. All the multi-parts were kind of the same weight.
Okay.
But they're all like a bunch of things to do. So like you'd be like, well, I don't know how to show this, but like I can take that equation and differentiate it and do what I need to get an answer to get the answer for parts like D and E. Then do parts D and E. You know, just collect some points. You know what I'm saying? Right? Like if I tell you show this is the equation and you're like, oh, I don't know how to get to there. But when I can take that and do something with it, then do that part. You know what I mean? You don't have to do the whole question. You're just collecting points. So like whatever parts you're like, oh, I can do that. Labeling a diagram, sure. Let me do that, 1 point. You know, like I'll take a point for doing that. It took me 30 seconds. You know, or like, here's the volume equation. I just have to tell you what the domain is for that. Yeah, I can do that. That's a point, right? Like, that's do the stuff you can do, right? You're stuck. Should we pause and
I think we should just.
okay?
Can I go to the bathroom?
Yeah, go ahead. All right. So what are we looking to do here? And the volume of a cylinder is going to be area of the base times its height. So in this case, that would be pi little r squared h. Everybody's cool with what we've done there? Assuming I'm using the labels from the picture I've given here. Now, what's the problem with that volume? There's two variables in it. R and H would both be variables. So I need to find a way to eliminate down to a single variable. Here's the tricky part on this one. You know what I'm going to eliminate down to? A third variable that's neither R nor H. That's the sneaky part. Now you could use R or H, but it's like going to be kind of inconvenient because the relationship that I'm going to need between so worth noting here, like cap H and cap R are constants. So that's what I'm going to be using to kind of eliminate my variable. So I notice that I have one right triangle here that involves cap R and cap H. And then I have a similar right triangle. Oh, I picked a different color there, you goober. I have a similar, or a right triangle similar to it here that involves little r and then this segment CD. I'm going to call that segment Y. So what I can say now is that R over Y is equal to cap R over cap H. And what can I say about little h here? How about it's h minus y? So what that tells me then is which variable do I want to get this in terms of? I want to get the r by itself so I can rewrite it in terms of y. So if I take that, the volume of my cylinder would be pi, and then cap r over y, or cap ry over h squared times cap h minus y.
Why did you get h is equal to big H minus y?
Well, if I look, h is going to be, or cap h is little h plus y, right? So it's this part plus that part, right? And then you can rearrange that any way you want. In my case, I want to get the h by itself, so I just subtracted. Now, eventually I'm going to have to differentiate this, correct? I guess this is a v of y because it's now in terms of y. And that's kind of el stinko to differentiate, right? Because I'd have to use the product rule and a chain rule, and it just would be like a whole kind of a thing. So I would start by just simplifying this. So I'm going to go ahead and do the exponent. I guess I'll write that as just a big fraction. And then I'll distribute that through. So this is what I would be using to do my differentiating, just to avoid having to do product and chain rules and stuff. Are we cool with that? Yep, I can wait for a minute. That's okay. Mia, is that a hand?
Yeah. How do you tell that why? Oh, the others are constant.
R, cap R, and cap H are constants, yes. Because those are just the dimensions of the cone. The cone is not changing. We're trying to find the cylinder, any cylinder that I can fit inside that cone that'll maximize the volume for the cylinder. The cone is stuck, so the dimensions for the cone are constants. That's why I know it's in terms of Y, because those guys are constants. Is that? And that's tough, right? That's tough to kind of like really think about, because you're sitting there looking at variables all over, or letters all over the place. Okay, before I go on and do my differentiating, let's just quickly do the domain. To do the domain, I'm going to look at the original formulation because it feels like that's just going to be easier. So I know Y is a dimension. So I know that it has to be positive valued. Everybody agree with that? And I know it has to be greater than or equal to cap H, because if it's bigger than cap H, my volume would be negative. Everybody agree with that? But that's not quite right. What's wrong with that? Can H actually be, or, oh, I'm sorry. Yeah, why can't it equal 0? Hold on one quickie. Okay, I did that and that, okay, and then do that, okay, and then I drop that in there, that's fine. No, I think that's okay. That's okay. Yeah, that's okay. That's the domain. Everybody's cool? How I came up with it? All right, let's do the derivative. What's the derivative? Should be easy peasy derivatives. What are we differentiating with respect to? Y. What is everything other than and then the Y? Constant. So what's the derivative of this first fraction? No. Just the derivative of y squared is 2y, and everything else just stays, right? Because they're just constants. What's the derivative of the second fraction? Y squared, though, right?
There's no like dy dt.
Oh, sorry, I just forgot to write it down. Thank you. No, because I'm differentiating with respect to y, and then the r and the cap r and cap h are constants, so they don't create a differential. Because I took the derivative of it. Derivative of y cubed is 3y squared.
Oh, I see. Okay.
Right?
Yeah.
It's okay? Is this okay so far? Yeah, go ahead.
Yeah.
Okay.
Oh, yeah. It was just a mental note.
Oh, okay. All right. So we did the derivative, right? And if you had this, getting to this is not that difficult, right? Even if you couldn't show how to get that thing that I wrote down as the volume, If you had that volume, you can take the derivative of it, right? That's not a big deal. And what do we do with the derivative now? We find the critical values. So we set it equal to 0. And what else do we have to check for? If it doesn't exist. Now, what kind of function is this derivative? It's a polynomial, right? Because it's just like a constant times y minus a constant times y squared, right? Just a derivative, or just a polynomial. Polynomials exist everywhere, so the only thing I have to care about is where the derivative is equal to 0. Now,
But what about the denominator of
h is a constant.
So if it was lowercase h, like hypothetically,
Mhm.
lowercase h is changed, right?
Yes.
So it's not, but it's not the uppercase, because the cone is not.
Yes. What's up, Victoria?
No, I don't even know. I think that's wrong.
So the h can't be 0. The height is, the cap h is the dimension of the cone. It's the height of the cone.
Yeah.
That thing is fixed. It's not a variable. If you had a cone with 0 height, that's a dumb problem because you can't inscribe anything in that because it's not a cone anymore, right?
Yeah, I understand.
Is that okay?
Yeah, I get it.
Okay. And that's fair, right? It's just sometimes it's tricky to kind of think through it. Okay. So I have a polynomial equal to 0. How do I solve a polynomial equal to 0? This is like algebra 2. Nope. No, you don't need a common denominator. No. Forget it. How about we factor? We factor. No, it's easy because there's only 2 terms. Both of them contain a y, right? Y is the variable we're solving for, right? Yeah, so what do we can take out? We can take out a pi, an r squared, a y, and an h, right? That gives me 2 minus 3y over h. Everybody agree with that? We can now use the zero product property to set each of those factors equal to 0. So there, y is just 0, right? And here, we'll subtract the 2 over, and then multiply by the reciprocal. So I'm going to use, since it's a closed interval, I just need to check the endpoints of my domain and my critical values. Oh, not in the derivative, but in the original, excuse me. And that's easy right away. Again, what are we checking with? We're plugging into this, right? When y is equal to h, this piece zeroes out, right? And when y is equal to 0, that part zeroes out. So both of those just have 0 volume. So clearly, this guy is going to be our maximum because I have no other choice, right? Everybody's agree with that? So like a one point of the problem might have been like, what values of y do I need to check to find my maximum? So it would just be like 0, 2h over 3, and h.
How do you know it's h? Just because it's like 1 minus
So what I'm using is is the closed interval method of finding a maximum minimum. So the domain was a closed interval.
Right.
So I can find the absolute maximum or minimum by looking at the critical numbers and the endpoints of the interval. In this case, the endpoints of the domain.
Also, H would be an endpoint.
So H was one of the endpoints. That's why I'm checking H as well as 0 and
How did we know H was an endpoint? Because it was on the.
that was the domain.
Okay.
The domain was 0 to H. So I have to check 0 and H automatically because it's closed, and then any critical values.
It's 0 to H because that's the height.
Because that was the domain. So I know that Y is a dimension, so it can't be negative.
Right.
So that means it has to be greater than or equal to 0.
Okay.
It has to be less than H because if it was greater than H, this piece would be negative,
Right.
giving me a negative volume, and that's nonsense also.
And I also can't. It couldn't be bigger than H because H is the height. Right. So,
Yeah, sure. You can think about it that way also. Sure. Mia.
How come it's closed if it, like, if it's equal to H, wouldn't it just become 0?
Yeah,
That's fine.
sure. Because there's nothing mathematically about having a 0 volume that's a problem, right? Things can have 0 volume. That's okay. Just, it doesn't exist. It's like a single point, right? Instead of having like a cone, you just have like a line. But like, fine, sure, whatever. That's dumb. It won't be that, but like, yeah, right. There's nothing mathematically wrong about having a 0 volume. Yeah. So now all that's left for me to do is to plug in 2h over 3 to find that actual volume, correct? Probably the place where I'll plug that in at is, oh, it probably doesn't really matter. I guess I'll use this guy up here. So I'm going to have pi and then r times 2h over 3 over h squared. Is that right? Yep. And then times h minus 2h over 3. Okay. So let's do some simplifying now. Here, those h's can cancel. And then what's h minus 2/3 h? 1/3 h. So if I simplify this out, I'm going to have 2/3 squared, so that's 4/9. And then I have an r squared. And I have the pi. And then I have cap h over 3. So that's going to be 4 pi r squared h over 27. So that would be my max volume. Sophia. Hi.
Have my
Oh,
fact sheet.
cool. Thanks, dude.
For you.
No problem. Is that okay? And again, like 120 points. If you're like, I am not good at optimization, don't spend a lot of time on it, right? Do the parts that you're like, okay, that part's easy. I can do that one little part right away. But if it's like the hard part really here was this at the very beginning, getting the volume down to in terms of one variable. If you're bad at that, don't waste a lot of time on it, right? Sergio?
What are like the big like story, like 10-point story problem questions related grades?
Yep.
This.
Yep.
And what else?
I think, did I put that here somewhere?
Wow.
Well, I highlighted the ones that we're doing here. Like that you should definitely like look over those ones for sure. So I would say like 65 I thought was a good example of something that I think could turn into a easy 10-point, like I can make a lot of parts out of that and ask you to do all kinds of stuff or something like that. That's a nice one where you're using anti-differentiation and then you're going and like, you know, like finding maxes and mins inside of that and like all that kind of jazz.
So it's like,
You know, like I think that like these piecewise functions in continuity, I think would make a nice multi-part question where I can ask you a lot about, you know, like where's this piecewise function continuous and discontinuous, and what's its derivative, and where's its derivative continuous and not continuous, and like prove that this is continuous here or not continuous or whatever. Like I think those are nice, would make a nice multi-parter.
4.3.
Well, it's really a chapter 2 idea because continuity is the main thing I'd be asking about, and we've been plotting piecewise functions right from the get-go. I think I just picked the one from 4.1 because I thought the piecewise function was nicer to work with or whatever, because we did 27, didn't we? That was one of them that I did. Did I not? Oh, yeah. Did we not? I highlighted it. Oh, yeah, there it is. Right, we did this one. And I just picked that one because we're looking for absolute local maxes and mins, and like finding where the derivative doesn't exist was going to be important to that question also. So it's just like I can combine a bunch of stuff into one problem that's chapter 2 ideas, chapter 4 ideas. It doesn't, you know, like it doesn't really matter. And I would say in general on the exam, you know, like there's things in chapter 2 that you could do easily using like chapter 3 ideas or chapter 4 ideas, like the limit problems in chapter 2, you can use L'Hopital. You could have used L'Hopital on if you knew what that was, right? The limit problems I'm going to give you are going to say just like evaluate the limit algebraically. Doesn't say that you can't use L'Hopital, use L'Hopital. Or if you prefer to use the methods from chapter 2, if those are applicable, use the methods from chapter 2. That's okay. You know, like if it's, you know, if you want to show something's continuous and it's a polynomial, then you like just say it's continuous because it's a polynomial, right? Like you can do that. You don't have to use the definition of continuity to do it. Like anything that you have that we've learned is at your disposal unless it says specifically like use the definition of a derivative to, you know, find the derivative of whatever. And I think we did an example of that. Well, everything's continuous on its domain, but it does if over over all real numbers it may not be continuous, right? With the only exceptions to that, Mia, would be things like, you know, like a step function or something. Yeah, like the round up, you know, like if it's anything greater than 2 rounds up to 3. Like that's something that's discontinuous on places other than its domain, right? Because that's defined for all real numbers, but has discontinuity at every whole number. But like, I'm not going to put something that kind of esoteric on there. Like it's a dumb function. It's really just an example for, we talk about it, so it's an example of something that's continuous or has its domain as all real numbers, but it's not continuous over its domain. Victoria.
should we like look back at like obviously look at our tests, but will some of it be like the ones I remember you telling us like the test format and like the ones that aren't going to be like story problem based, they're going to be like normal ones like I just look back.
I would say in general, preparation-wise, I built your final exam more from your homework problems than I did from like Mr. Kulik originals or like former AP questions, which is what some of the stuff Mr. Kulik originals were based from, were old AP questions that I found that I've like harvested a free response question for just the parts that were relevant to what we were doing. but I would say in general here, I looked at the homework problems that I assigned you that you probably spent the most time working on. But there's certainly, like, especially the multi-part problems are going to have stuff all mixed together. You know, you might have a problem that has chapter 2, 3, and 4 ideas all in the same problem, right? And it's not absurd. And the test is in no way arranged so that, like, here's a chapter 2 question, here's a chapter 3 question, here's chapter 4 question. They're just like, they're all mixed in there with no rhyme or reason. It was just like, as Mr. Kulik came up with something he liked, it's like, okay, I'll write a question here. And I just jumped around. Okay, so, like, don't be looking like, okay, the chapter 2 stuff is at the beginning. Chapter 2 stuff's mixed all in there. Chapter 3 stuff won't be in the middle. It's all mixed in there. Chapter 4 stuff, not at the end. It's all mixed in there. You know what I mean? And I'm not trying to do that to be mean, right? Why would I do that and have it all mixed in there? What's the AP exam going to look like? It's all mixed around, right? You have to recognize, like, what can I use to do this? And that's probably the hardest part, is making sure that you recognize what to do, like, what can I use to do this, or what should I be using to do this when you read the question. You know what I mean? And that's part of the reason why a lot of these questions won't have, like, hyper-specific directions. Like, it'll just say, take the derivative. Because I don't care how you do it, whether you use logarithmic differentiation, or use the definition of a derivative, or use, like, product quotient chain rule, or whatever, right? Like, the majority of those kind of problems are just going to say, take the derivative. Or it'll just say, find the limit. Do I care if you multiply by, like, 1 over x squared to the top or bottom, or use L'Hopital twice? No, I do not. Either is fine for a certain problem. Either could be doable. Mia.
So when you are multiplying by like 1 over x squared,
Mhm.
is that based on the denominator? Like, how do you think it's like at the top is like x squared, at the bottom is x cubed, and then 1 over x.
Well, you want it. The goal is to not end up with an indeterminate form. So, like, or something that's undefined, ideally. So to do that, you'd want to get the variable, or to have no, after you do the limit, you'd want no variables left in the the denominator, because you don't want a 0 denominator, right? I guess, right? But it just kind of depends on what's the, like, what thing is where, you know what I mean? Or you can just L'Hopital it, right? And then you don't have to worry about it, because you just keep L'Hopitaling until you get something you can evaluate.
No, after this.
Yes.
If you have a good grade.
Well, the AP classes, you don't have a final exam, period.
Or IB finals.
Because you have, it's really like 4 months, because it's the end of January. Like, you have all of January, all of February, all of March, all of April. Right. But that's 5 months, if you count that. All of January, February, March, April. Oh, okay. You don't have May. That's the month you're not counting. Yeah.
But also, counting in the sick days.
Yeah, sure. The Sophia sick days.
Yeah.
The Sophia and
Just as a heads up, I'll be around after exams. So if you need to come find me and ask me about something that you've been going over and you're like, yeah, I don't know what to do with this, I'll be around on, like, Thursday and Friday this week. That's what I mean, after exams.
Okay.
Yeah, like Thursday and Friday if you need to catch me. Okay?
Will do.
Weekend's going to be hit or miss. Probably mostly miss.
Oh, same.
So, I think it's time for you to go if you're ready to go. Have a good day.